Hi, welcome to Coding Class with MasterHun, Season 0, Episode 13. Okay, today yesterday, I have on Wednesdays, currently Wednesdays, I teach a small group class, Python coding/Python class in Brea. Small group class, only me and two students. Yesterday it was just me and one of the students. The other student was absent that day. So what the project that we're working on all together, we're working on. I selected the topic. It is the game Farkle. I don't know if you've ever played Farkle or not, but if you go to Google and Google Farkle, Farkle, I can select this. If you Google Farkle, Farkle, and then you can see there's even a Wikipedia page. There's videos, YouTube videos, and also like I said, there's a Wikipedia page, and you can download the rules. There's a PDF. I don't see it here, but there's a PDF file you can download that is the same rules that comes with the game if you purchase it. So the main point of Farkle is to give it's not possible. Of course, it's not possible in even one or two or three 90-minute sessions to teach anybody what design patterns are. And I'm not saying I'm an expert in it. I'm not an expert in design patterns. But okay, first of all, design patterns, which has nothing to do with sewing. So this has nothing to do with sewing. It's design patterns as it refers to coding projects, computer programming. Okay. So basically, the idea of design patterns is really actually quite simple. It's the idea of you've solved the problem before. Is there something about or the class or category of problems that you've solved before that what can you abstract or generalize from previous problems and then apply it to other problems or future problems where it's not always clear what the solution will be. So a competent coder will always practice reduce, reuse, recycle. So you should always be thinking of how can I not only reduce the code, how can I reuse the code, how can I recycle code? Can I just use the same code, maybe with a few changes? Or can I reuse some of the code, hopefully with not with a minimum amount of changes? A competent coder should not be doing everything from scratch. Yes, a lot of coders do things from scratch. They just, they don't reduce, reuse, or recycle. They just do everything from scratch, which I think is a complete waste of time. If possible, you should try to reduce, reuse, recycle. Okay, you should always be thinking that you should always have that in the back of your head. How can I reduce code? How can I recycle code? How can I reuse code? Okay, so the game Farkle is relatively easy to understand. Basically, you have six-sided dice, and in the game that you can buy retail, it's you get you get a rule book, you get score sheets, you get a plastic cup, a sturdy plastic cup to roll the dice in, and you get six-sided dice. So basically, the six-sided dice has six sides, obviously, and you have six numbers on it: 1, 2, 3, 4, 5, 6. So in the first roll, you would roll all six dice, and from the numbers that you roll, you normally you want to have the highest score possible. So in this example, right, if you look at the output, I rolled a 1, 2 3s, 2 4s, and a 6. And according to the rules of Farkle, I think that only gets me the 1. The 1 only has any value. So then these other 5 dice, they didn't score me anything. So the maximum score I could get from this would be 100, because 1 equals 100 in Farkle. I got rid of my rules. Why did I do that? I'm gonna bring back up my rules. See what it is. The rules. Now the way I'm doing the code, I'm starting from the highest possible score to the lowest possible score. So I haven't done anything with the lowest possible scores yet. I'm only working on the highest possible scores right now. And the highest possible score is 3,000. I'm sorry, 3,000. You can score 3,000. So in order to score 3,000, in order to score 3,000, you have to get, if you can read this highlighted here, when you roll all 6 dice and all 6 roll the same number. So for example, if you can read this example here, if I roll all 6 dice and I get 1, 1, 1, 1, all ones, or all 5s, right? 5, 5, 5, 5, 5, 5, 5. If I roll all 5s, then I get the highest possible score with a roll of 6 dice, 3,000. Okay. Unfortunately, because if we look at line 9 on the left here, we can see that I import random. I import the random module. Now, again, the classic computers are deterministic. They are not able to actually generate actual random numbers. They generate what we call pseudo-random numbers. More or less, they look like random numbers, but they are actually not random numbers because it's done by a formula. So they're numbers that you should not use for cryptographic purposes or encryption. That would be a bad idea. But they're good enough for video games, right? It's not good enough for video games or dice, or in this example, a dice game, right? Dice game. But because these are not actually random numbers, it's generated again. This is a classic. Most computers that most people use. Very few people have access to a quantum computer, of course. So these are classic computers. Classic computers are deterministic. They cannot actually generate real random numbers. They can only generate pseudo-random numbers. So the possibility of getting the possibility of getting all 6 of the same number is, because of the nature of the pseudo-random number generator, I believe that's actually 0. It's not possible. It's not possible to get all 6 of the same numbers. All 6 of the same number. So I'm running the code again, and what do you got? I got a pair of 1s, a pair of 4s, a 3, and a 5. So the 5 is worth 50 points, and the 2 1s, they're worth 100 points each. So this would total, and this pair of 4s, that's worth nothing. This 3 is worth nothing. So this on this roll, I would have a maximum score of 100, 100 plus 50, so it would be 250. And then I could roll these 3 dice again. And just to give you a little bit more, the point of this episode is not to go over all the rules of Farkle. I mean, you'll learn that as in parts. I'm thinking parts 2 and 3. This is part 1. This episode is part 1 of the project Farkle. So probably with 2 and 3, by the second episode, after the second episode, you'll have a fairly good idea of how the Farkle game works, scoring works. But just to let you know, so in this situation, I would have a total of 250 points, and then I still don't score. My total score is still 0 because you need to score at least. I believe you're right. You need to score at least 500 points. You need to have at least 500 points. What is the? I have to look at the rules. Yeah, you must have a rolling total of 500 points before you can stop rolling, and then you would have whatever 500 or whatever points actually gets added to your total score. So actually, after this first roll, so with the highest score of 250, still wouldn't be enough. So I would still have to keep rolling and trying to get at least 500 or more at least 500 or more points, and then I can stop if I wanted to. So I would have to roll. Another second time with 3 dice, and hopefully I can score 300 plus points, and then I can record it and stop potentially. But anyway, so now, okay. So I have to explain to you that, yes, right, we need to, in previous episodes I already talked about import and the random module. So, okay. So first I need to import the random module. Now where am I going to put these rolls? So in order to represent these dice rolls, I created an empty list. I created an empty list which will eventually will contain these dice rolls, and they will be integers. Keep in mind that generally when there are dice in here, the rolls will eventually have 6 slots or 6 items for 6 dice. When the dice has been rolled, the result of the rolls will be represented by an integer from 1 to 6. So a number between 1 and 6 means that that's a result of a dice roll. If the number is 0, then that means that's an empty slot. To represent a situation where we're rolling less than 6 dice. I don't know if that made any sense. Okay. Now I haven't created it yet, but because this is still in a work in progress. So we have another integer. I have an integer, a single integer variable called highest underscore score, or just highest score, and this will be the highest possible score. It will the code will determine what is the highest possible score given the whatever the integers are in the list rolls. So it'll figure that out for you. You don't have to. In other words, the code will do all the thinking for you. The only thing the user will have to do is just decide: do I keep rolling or do I stop and just keep whatever points that I have? So highest underscore score. Highest score is one variable. There will be another variable I haven't created yet. It will be called total score, because in the game you need to keep a running total score that helps you to figure out whether you've won or lost compared because you need to, once you've reached, if you're playing against other players, the first player to hit 10,000 or more than 10,000 points, that's when the game will end. That's when the game will end. And then the other players will have one more chance to roll. And if they can't beat the first player's 10,000 points, whatever 10,000 plus points or whatever it is, then the first player that scored 10,000 points or greater wins. So I have a highest score variable, but eventually I will be creating a total score variable, both integers. Okay, now how do I generate these random dice? So I have a for loop. I have a for loop that will, and this will probably change, but generally this is a for loop. So I have a for I in range 6, because this will probably change range 6 because I needed to generate 6 random integers. So, and then I needed to append or add it into the list roles. So I use the append method. Okay. Now, in order to generate the dice rolls, I call the random module, and inside the random module, I call the rand init method. And I need to generate a number between 1 and 6. So that's the lowest number. 1 is the lowest number, 6 is the highest number. Okay, and it's going to do that 6 times. This will probably be modified in later episode, in episode 2 or 3, I think. Okay, now this is really important. I need to sort the integers in the list roles. Okay, because then that will make it possible, actually literally possible, for me to determine what the highest score for those set of roles, those set of integers are. Okay. And then here I print line 32. I print out or display what is the result of the rolls, so I can tell whether or not. So me, the user, right? So we can see something here in the output area, right? And we can see what did I roll? What did I roll? Okay. Okay, now we're at the, okay. Now this part here is it's pretty big if, elif, else statement, or in other Golang languages you could think of as a switch. But basically, just the general pattern. So the general pattern of this conditional statement, this long conditional statement, this huge block of code, it figures out what the highest score is, given the 6 integers in the list roles. So the pattern is, and it's very similar to the pattern I used before with FizzBuzz. In FizzBuzz, so you give the function FizzBuzz, the FizzBuzz function, you give it as an input an integer. And then it will return the string FizzBuzz, or the string fizz, or the string buzz, or it will return the same number, because it's neither FizzBuzz or buzz or fizz. So in the logic of FizzBuzz, in the FizzBuzz function, I check for FizzBuzz. Is the integer evenly divisible by 15? And if it is, then I return the string FizzBuzz. And then after that, I check for fizz and then buzz. And if it's neither fizz nor buzz, if it's not FizzBuzz or fizz or buzz, excuse me, then I just return the same integer. So I'm using the same pattern here, where I'm checking for the least likely condition. So the least likely condition is if I get 6 of the same number. For example, if I get 6 1s, or if I get 6 5s, Okay, so if I get 6 of the same number, I score the highest possible. This is the highest score possible with a roll of 6, 3,000 points. 3,000 points. Okay. Now, what's interesting is, and this is the condition that we're looking for in this if statement. The condition that it's checking for is the first number rolls index 0, and the last number rolls index 5, right? The first number is the first number and sixth number, sixth number. Are they the same? Because the integers in the list rows are sorted from lowest to highest, if they're the same, then logically all the numbers in between must be the same. So I don't need to check for each number. I only need to check that the first and the sixth number is the same. And actually my student pointed it out to me and helped me to realize, yeah, because before I was making sure all the numbers were equal to roll 0, roll 1, is rows 1 equal to rows 0 equal to rows 1, is rows 1 equal to rows 2, is rows 2 equal, yada, 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 until is rows 4 equal to rows 5. But he helped me to realize they're sorted. I don't need to do all that. I just can reduce. Essentially, I'm reducing the one big conditional into a much shorter, easier to read conditional. Is the first number, rolls 0, equal to the last number, rolls 5. Okay, because if the integers in the list rows are sorted from lowest to highest, if the first number and the last number are the same, then logically all the numbers in between must be the same. They must be the same number as the first number and the last number. So he helped me to realize that and make the code much more readable and shorter. So reduce, right? Reducing code. Okay, so unfortunately, this is the least likely possibility. Again, because of the fact that this is a classical computer, it's deterministic, and the random module is actually a pseudo-random mod. It generates pseudo-random numbers. It's not an actual real random number generator, because classical computers are deterministic, and they just can't do that, because of the nature of a classical computer. Okay, so I start off with the highest score, which was 3,000, right? So the next highest score and the next least likely possible highest score would be 2,500 points. Now, how do you get 2,500 points? You get 2,500 points if you get 2 triplets or 2 triples. Okay, so an example would be 3 1s and 3 4s. Okay, 3 1s and 3 4s. Okay, again, because the list rows get sorted from lowest to highest, right? Because the list rows get sorted from highest to lowest, if you roll 2 triples, the first item in the list, roll 0, must be equal to the third item. Okay, we don't need to check the second item. We just need to make sure that the first number and the third number are the same. And the fourth number, rolls 3, has to equal the sixth number, rolls 5. Okay? If the first number and the third number are the same, and again, because the list rows is sorted from lowest to highest, if the first number and the third number are the same, well, the second number must be the same number. Okay? If the fourth number and the sixth number are the same, then if the fourth number and the sixth number are the same, the fifth number must also be the same number. Okay? Because again, they're sorted. The numbers are sorted from lowest to highest. Okay? So if this condition is true, then we have 2 triples. So if we have 2 triples, then the highest score for this would be, of course, 2,500 points. Okay? Now what is the next highest possible score? And that would be if you got 5 of the same number. Okay, if you rolled 5 of the same number, then you would get the next highest score would be 2,000 points. So you rolled all 6 dice, and you got 5 of the same number. And for example, would be you got, okay, this is a bad example. This is not good. This is not good. This is not a good example. I did this wrong. Oh boy, let me fix this. Okay. This is not, oops. I'm sorry. Here we go. This is. You know, this is not a good example here. This is not a good example. Computer fixed it. Sorry. Apologize for the delay. What am I doing here? Okay, here we go. Does this make sense? Okay, here we go. Okay. Save that. Okay, save that. Okay. 1, 2, 3, 4, 5. Okay. Okay, so if you can see this condition here, we have this condition. So there's 3. So if I roll 5 of the same number, I have 2 possible conditions. Again, because the list rolls is sorted from lowest to highest. So either at the front I'm going to have 5 of the same numbers, or I'm going to have 5 of the same numbers at the end, at the back. Okay, either at the front or the back. Okay, so if I have 5 of the same numbers, again, the list rolls is sorted from lowest to highest. So if I have 5 of the same numbers, then I'll have one possible situation where it's at the front. So the first number and the 5th number are the same, and then I don't have to do anything with the numbers in between, because they're ordered, they're sorted from lowest to highest, so they must be the same. Okay. Now, it's also possible, because it's sorted, also because the numbers are sorted from lowest to highest. It's also possible that I will have the second number and the 6th number, so the same number from so the second number, so it would be at the back end. So the second number and the 6th number to the 6th number would be the same. Okay? So if I have that situation, then the second number and the 6th number rolls 1 and rolls 5, right? They must be the same number. And all the numbers in between them must also be the same. But I don't have to check the numbers in between. I just need to check either it'll be at the front, the first number and the 5th number will be the same, right? Or the second number and the 6th number will be the same, okay? Because if I rolled 5 of the same number, then I have only those 2 possibilities, okay? Again, because the list rolls get sorted from lowest to highest, okay? So if that's the situation, then the highest possible score would be 2,000, okay? Okay, now we get to now it gets much more complicated, because the next highest possible score would be 1,500 points. But with 1,500 points, you could have 3 different situations. So we could have a situation where if you roll 3 pairs, okay, if you roll 3 pairs, like in this example, right? I rolled a pair of 1s, I rolled a pair of 3s, and I rolled a pair of 4s. So if I rolled 3 pairs, I get 1,500. I get 1,500 points, right? I score 1,500. That's the highest score. So in this situation, I have one very long condition, right? The first number and the second number have to be equal, right? So they're the same, right? And right? And the third number and the fourth number must be equal. And the fifth number and the sixth number must be the same. Okay? So it has to, this is one, right? So it has one long and. So these three conditions have to be satisfied, and then, which means that I have 3 pairs. I have 3 pairs, and then you will get awarded 1,500 points. Okay? Now, there are 3 possible situations where you can get the highest score of 1,500 points. Okay. Now, you could get 3 pairs, or you could get, what is this? You could roll 4 of the same number and a pair. Okay. For example, you could roll 4 ones, 1, 1, 1, 1, and 2 fours, 4, 4. Okay. If you do that, if you roll 4 of the same number and a pair, you will get the highest possible. Your highest score would be then 1,500 points. Okay. So in this situation, we have. So this is we could have. So in order to get this one, so if, again, because the list roles is sorted from lowest to highest, so if you got 4, if you had a 4 of the same number and a pair, either you would have the 4 of the same in the front and the pair in the back, or the opposite. You would have the pair in the front and then the 4 of the same in the back. Okay, so if that's the situation, then the first number and the fourth number has to be the same numbers. They have to be equal. And the fifth number and sixth number would have to be equal. Okay? So in that situation you would have 4 of the same in the front and a pair in the back. Or you could have the pair in the front rolls 1 and rolls 0 and rolls 1. The pair in the front, so those 2 numbers would have to be the same. And then you would have to have the third number and the sixth number would have to be the same. In other words, rolls 2 would have to equal rolls 5. Okay? So either you would have the pair in the front. I mean, so either we have the 4 of the same in the front and the pair in the back, or we could have the pair in the front and the 4 of the same in the back. Okay? So if we have that situation, then your highest score would be 1,500 points. Okay. Now, there's a third possibility of earning 1,500 points, and that is if you roll a straight. Okay, and this is really simple. This is simple to understand. There's only one possible combination to roll a straight. So the result of your rolls, right, the numbers in the rolls, right, the list rolls, would have to match exactly this order, right? Again, the list rolls get sorted from lowest to highest. So if that's the case, if you rolled a straight, then it would be equal to this list. This list would be equal to the literal list 1 of integers 1, 2, 3, 4, 5, 6. Okay, if you rolled a straight, then it would be equal to this, and your highest possible score would then, of course, be 1,500 points. Okay. Okay. So. Okay, this is wrong. I'm sorry, the text is all wrong. Okay. Okay. Now, okay, so we did 3,000. How can you score 3,000? How can you score 2,500? How can you score 1,500 points? Now we go on to the next lowest or highest, next lowest possible score would be 1,000 points. How do you score 1,000 points? You would score 1,000 points if you got 4 of the same number but no pair. So in this situation, you would have the 4 of the same number in the front, or you could have it in the middle, or you could have it at the back. Okay? So then we have to account for that, right? So if you have 4 of the same number in the front, then row 0, the integer row 0 must be equal to rows 3. And again, because the list rows is sorted from lowest to highest, so we don't need to check any numbers in the middle. If the first number and the fourth number are the same, then all the 2 numbers in between must be the same numbers. So we don't need to check those numbers. We only need to check the first and the fourth number. And if that's true, then you must have rolled 4 of the same number in the front. Now it's also possible that, you have 4 of the same number in the middle, because there's 6 slots, right? So the second number and the fifth number, if they're the same, then the 2 numbers in between those must be the same, right? So then you must have rolled 4 of the same number. Excuse me. Okay. Or the 4 of the same numbers are at the end. Okay, again, because there's 6 slots, right? But you didn't get a pair. And we don't have to worry about, this is the point. We don't have to worry about in this, so once we go down to this if elif condition, we don't have to worry about, are the other two numbers a pair? We don't have to worry about that, because that was already checked for previously, before, right? Before we were checking for 4 of the same number and a pair. Okay? So once we come down here, right, we checked that before. So if that wasn't the case, then we must have ended up this. So logically, there's no pair. There's only 4. So now we're checking for if the list rows contains 4 of the same number and no pair, then logically this is where we are now, right? So we don't have to worry about like are the other 2 numbers that's not 4 of the same, is it a pair or not? We don't have to worry about that because that's already checked. We already checked for that earlier. Okay. So again, if we have 4 of the same number and no pair, it's either going to be at the front or in the middle or at the end. Okay. And we don't have to check all 4 numbers. We don't have to make sure all 4 numbers are the same. We only need to check that either the first number and the fourth number are the same, or the second and the fifth number are the same, or we need to or the second and the sixth number are the same. The third and the sixth number are the same. Okay? If the third and the sixth number are the same, then we have 4 of the same. 4 of the same. If the second and the fifth number are the same, then we have 4 of the same in the middle. If the first and the fourth are the same, then we have 4 of the same number in the front. Okay, front, middle, or back. Okay, and then then you would get the highest score would be 1,000 points. Okay. Now finally, we're not finished with all the logic. There's still more logic to go. So I feel like this is more like at this point in the project, I feel like we are now at probably like 30 or 40%. I think there's still a lot more logic to go through. And then if you read through the rules, you will notice that there are a lot of interdependencies that you have to account for. So, but anyway, so we're not done. There's still more logic to go. We're not done with all the possible scores. Okay. Now, in this elif, right, what are we looking for? Okay, we're looking for a situation where we have where we have 3 6s. Okay, this was I don't know what I did this wrong. Let me fix this. This is a bad example. That's not an example I want to use. not a good example. This is not a good example. Okay. So, okay. Again, because the list roles is sorted from lowest to highest. So what we're looking for here is, do we have a triple? Do we have 3 6s? So if you roll 6 dice and you get 3 6s, and again the list rolls get sorted, and then we roll 3 6s, the list rolls get sorted. If you roll 3 6s, then the 3 6s will always be at the end. It'll always be at the end. So it'll be at slot 4, 5, and 6, or so. And again, because the list rolls is sorted from lowest to highest, so in that situation where if we did roll 3 6s, they would always be at the end. We know that. So we only need to check if the 4th number and the 6th number are equal to 6. Okay? Is the 4th number, or in Python encoding, so it would be rolls square brackets 3, is that equal to rolls square brackets 5, and is that equal to the integer 6? So if that's the situation, then you rolled 3 6s, and then you would score 600 points. Okay, that would be your highest score. Okay, and then this would be a possible example, right? So it wouldn't be possible if you again, because the list roles get sorted from lowest to highest, it's not possible that you could have 3 6s in the front. Because in order for it to have 3 6s in the front, then the three slots in the back, they would have to be 7 or greater. Which doesn't make any sense, because these are 6-sided dice, and the random number, when we generate the random numbers, the highest number possible that can be generated would be a 6. So you can't go past 6. Okay, so given that, I only need to check the 4th number. I only need to check the 4th slot against the 6th slot, right? Or in Python, it would be rolls square brackets 3. Is that equal to rolls square bracket 5? And is that equal to 6, right? So are those two numbers equal to 6, in other words, right? So if those two numbers 6, I don't need to check the number in the middle, because again, it's sorted from lowest to highest, right? So the number in the middle must also be 6, right? I can assume that. I can assume that must be true, right? So then that's the situation. If that's the situation, if the 4th number and the 6th number are equal and they're both equal to 6, then I must have rolled 3 6s, and the highest score then would be 600 points. Okay. And unfortunately, Farkle has a lot. Farkle, the rules are relatively simple, but they have a lot of interdependencies. So it's relatively, I think it's relatively straightforward to code, but there are a lot of things you do have to keep in mind and work out in the code, interdependencies. So I think that's going to take time. So I'm imagining that it will probably take 2 more episodes to get most of this code, most of the logic worked out. Okay. Well, thank you for following along with me. This was a really long episode. Thank you for staying with me. I wish you all the best, and I will meet you in the next episode. Thank you very much.